Grouping is another form of factoring. The first step is taking your two different terms and separating them. So let's just write that down. X cubed plus 3x squared minus, plus minus 4x minus 12. Next, you're going to want to take out the greatest common factor. The greatest common factor of the first term, let's see, x cubed plus 3x squared. They both have x's, and they both have 2, so the greatest common factor is going to be x squared. Then you write what's left, x plus 3 plus. Now, let's see, what's the greatest common factor here? There's negative 4x minus 12. They both have a negative 4, and you can't go higher than that, so the greatest common factor is negative 4. And if you look, we brought down the same sign that was in between them before, which is always a good sign. Next, you bring down what's left, which is x plus 3. X squared minus 4 x plus 3. But there is still some more simplifying you could do there, so let's do that. You can do x minus 2, then x plus 2, and finally x plus 3. And that's taking the x out of all the scenarios here, and then taking the number variables and splitting it into 3 different answers. And there you have grouping. Okay, GCF, greatest common factor. What if you're given a crazy example like this? CX plus CY plus DZ. What's the greatest common factor for that? For problems like this, there is none. You can count them as prime, or write no GCF. Super simple. Yay. We're going to start with a very simple special case binomial. The equation is x squared minus 64. So using the formula a squared minus b squared equals a minus b times a plus b, we're going to factor out the expression. So if this is a squared minus b squared, then I'm just going to factor it out like that. So let's put some parentheses and factor it out. We're going to put x because there are 2 x's here, minus and then plus, and the square root of 64 is 8. Super simple, and that's your solution. Here's a little bit harder special case binomial. The equation is 3a to the power of 4 minus 48b squared. Now, again, using this equation or formula, a squared minus b squared equals a minus b, a plus b. Also, you should always be setting your equations equal to 0. Don't forget that. That's not good. So assuming this is your a term squared and your b term squared, you're gonna, well, first, greatest common factor, factor that out if you can, which here is 3. So that becomes 3a to the power of 4 minus 16b squared. Next, now using the equation, or the formula, a squared minus b squared equals a minus b times a plus b, we're gonna do 3, add those parentheses in, next, a to the power of 4 divided by 2, a squared and a squared, and the square root of 16b squared is just 4b, and that's what you put on both sides. And then you're going to want to add your signs, which one will be negative, like this, and one will be a positive. And those are your solutions. Okay, GFC, greatest common factor. You should always start by looking for a greatest common factor. Here's our equation, 60m squared n minus 48mn squared plus 72m cubed n. Now, this equation might look very big and scary, but it's really not. If you think about the greatest common factor, just find the greatest common factor of the numbers. In this case, that's going to be 12. And then let's look at the variables and see what we have. There's an m in all of them, but not everyone is m squared, so that's just going to be an m. And there's also an n in all of them, but not all of them are squared, so that's just going to be an n. And that's the greatest common factor for this. And next, you just figure out what's left. After that, it's 5m minus 4n plus 6m squared. You're just finding out what's left in the terms after 12 is factored out. There you go.
So the sum of cubes, is one of the equations that we use in Algebra 2. So the sum of cubes can be used to solve an equation which incorporates two different values that both are cubed. So to begin with, I'll give you an example of one of these equations. So x cubed plus 64. So how do you solve this? Well, you follow the sum of cubes. And the equation for that is going to be parentheses. Oops, sorry, my mistake. It's going to be a cubed plus b cubed is equal to, so a cubed, a corresponds to the first number, the variable typically, and the b corresponds with the second number. Now, this number must have a cube root in order to be able to be solved through the sum of cubes. In this case, it is. So here we're going to see a cubed plus b cubed is equal to a plus b, and you close the parentheses, equals a squared minus ab plus b squared. So that's the value that you're going to use with the sum of cubes. You see that this is a negative instead of a positive. It's different to the difference of cubes, which I'll get into later. So to solve this, here's how you do it. First, you take the a value, which is, again, that a cubed plus b cubed, which is here going to be the x and 4. So x cubed, obviously, is x to the third, as you see up here. X plus 4. 4 times 4 is 16. Just write that over to the side. 4 times 4 is 16. And 16 times 4 is equal to 64, our b value. So x plus 4, then you draw another parentheses, and you're going to see x squared, because x squared is, again, that a value. So x times x is x squared, minus 4x, so a minus b, minus ab, x times 4 is 4x, plus b squared. Now b squared, again, is 4, so 4 squared is 16. And from that, you're able to get this final answer. Parentheses x plus 4, close parentheses, times, and times is here represented by the two parentheses, x squared minus 4x plus 16. So that's your answer. Let's do another example of the sum of cubes, one that may be a little bit more challenging. So we're going to do this one. 3x to the third plus 3 equals 0. That's set to standard form. It's not necessary all the time for sum of cubes, but I do it sometimes just out of habit. So first we're going to pull out the greatest common factor, which in this case is 3. Both of these numbers can be multiplied by 3. So by doing this, we get 3 parentheses x cubed plus 1. So now that we have this set to 0, now that we have this, we can begin doing this equation, a plus b times a squared minus ab plus b squared. So it's a little more tricky when you have a 1, but it follows the same principle. Some people can get caught off by it, but it's not that hard. So since we have a GCF, we have to put that right at the beginning. And then we move our x value, so it's 3x. Again, here we have our a value, and here we have our b, and this is our GCF. And I'm actually going to move this a line down because I wrote those there. So we have our 3, our GCF, times our a value, which is x, plus our b value, which is 1. Then we have our x value squared, so it's going to be x squared minus our ab. So since our b value is only 1, it just stays as x. Plus our b value squared. Now 1 squared is still equal to 1, so that stays 1. And so your answer ends up being 3 times x plus 1 times x squared minus x plus 1. And there you have it. That's the sum of cubes. So now we're going to move on to what I mentioned earlier, the difference of cubes. Now, the difference of cubes is really similar to the sum of cubes with one twist. So, as we saw earlier, the sum of cubes, your equation there is going to be a cubed plus b cubed equals, and again, this is the sum of cubes. I'll write that off to the side. Sum of cubes. Your equation for that is going to be a plus b squared, a cubed plus b cubed is equal to a plus b, parentheses, a squared minus ab plus b squared. Now for the difference of cubes, it does actually have a different equation, only slightly though. So when you have sum, that means addition, difference means subtraction. So a cubed minus b cubed equals a minus b, parentheses, a squared. Now here it's instead of being a minus, here it's actually a plus. So a squared plus ab plus b squared. So you can see that the equations differ in, one, the actual values that you're trying to solve for, and two, the signs. So these signs become flipped, and so do these. So an example problem that you might see for the difference of cubes could be something like this: 27x cubed minus 8, let's say. So I'm going to set that to 0, as I do most of the time. And now you can solve it. So first I'm going to find out what the a and b values are. So my a value is going to be what cubed equals 27? So it's 3. So 3 times 3 equals 9. And 9 times 3 equals 27. But that's not necessarily my a value because I still have the x. So my value is actually going to be 3x. Now my b value is going to be 2 because 2 times 2 is 4. Quick maths. And 4 times 2 is 8. So now that I have my a and b values, I can start to plug them into this equation. So my 27... my a minus b cubed is going to be 27x cubed minus 8, which is equal to, parentheses, 3x minus 2, because again, you have to remember the minus, unlike the sum of cubes, times 9x squared plus 6x, because ab, so you'll have 3x times 2. Sorry, I'll write that down here for here. So 3x times 2, so it's going to be 6x, plus 4, because b squared is obviously 4, so you get this number here. So this actually ends up being your value. 3x minus 2, parentheses, 9x squared, plus 6x, plus 4. And that's basically the difference of cubes. Again, it's very similar to the sum of cubes, just with opposite signs. For 1, it basically stands, if you have a value that incorporates 1, as we discussed in the last one, the 3x plus 3, the 3x cubed plus 3, excuse me, it basically stays the same. Except for those inversions of signs. So that was the sum and the difference of cubes. Thank you.
So what I'm going to teach you is factoring by decomposition, and we have our equation. So first we're going to draw an x next to it so we can find the values. And remember that everything must be set to standard form, so equal to 0, which I have down here. So on the top, we're going to put the a term times the c term, which in this case is -3 times 2, which is -6. Then on the bottom, we're going to put b term, which in this case is -5. On each side, we're going to put whatever multiplied equals to 6 and whatever adds to -5. So in this case, it would be -6 and +1. Then after you're done doing the x thingy, you're going to factor out the expression. Always setting it equal to 0. Then factor out 2w then split it into two equal equations to 0. Then move on to solving the equations. Whoops, sorry. And the final step is your solutions, which would be W1 equal to negative 1/2 and W2 equals 3. And that's it. On this problem, we're going to do a little smaller one. It's going to be 3x squared minus 75. So, like we did before, we're going to put an x on the side, and we're going to put the a term times the c term on the top, which is going to be negative 25. On the bottom, we're going to put 0 because there's no b term. On the side, it's going to be plus 5 because 5 times 5 multiplies to 25. And then on the other side, of course, we're going to put negative 5. Then we're going to go ahead and factor out 3 from the expression. After that, using terms a squared and minus b squared, we're going to factor the expression like this. And our final answer is
Nope.